Hey everyone, today we're going to be talking about z-scores, an area under the curve. So we've already talked about our patterns and percentages that we need to know for a normal distribution, but sometimes we're not dealing with such a nice value. Maybe one of our values is not one of those specifics on that normal curve. Okay, so we're going to talk about something called z-scores today. And to calculate your z-score, you're going to do the following. So here's your formula. Z equals x minus mu over sigma. Now remember, you already know that mu is your mean, okay? And sigma is your standard deviation. So the two new variables here are x, which is just your element in your data set, and z, which is your z-score, basically telling you how many standard deviations you are away from the mean. So let's look at an example. So it says a normally distributed data set of 500 values has a mean of 30 and a standard deviation of 10. What is the z-score of 27? All right. So to find our z-score, we're going to use that formula from above. All right, so we know that our element in our data set is 27. We know that our mean is 30. And we know that our standard deviation is 10. So there's our setup. 27 minus 30, of course, is negative 3. And negative 3 divided by 10 is negative 0.3. So that's our z-score. And we're going to talk about what that means here in just a moment. So let's go to the next slide. So what does that z-score of 27 mean? So remember, our z-score that we just got was negative 0.3. Well, there's this great thing. It's a z-score table, and you are given percentages from it. So z-scores represent a standardized percentage or percentile, and percentages are always measured to the left. So it's always going to tell me the percent that gets that score below. All right, so on your Z table, there's a positive and a negative side. So this is obviously the negative side. And so if we want a Z-score of negative 0.3, we're going to scroll down a little bit further. So we see, oh, here's negative 0.3. And because there's nothing else after that, there's nothing in your hundredths spot, okay, you're going to be using that column. So they meet right here. So you notice there's a decimal of 0.3821, but this is actually a percentage. So if I change this to a percent, it's 38.21%. Well, what does that percent mean? So what that means is that 38% of the data is less than 27. So say, you had some sort of test, okay, and I'm not sure what the maximum grade on this test is, but say you got a 27. So you scored below the average, but you still scored better than 38% of everyone else taking this particular test. And I'm going to show you how to calculate this percentage on Desmos, which is primarily what we're going to be using. But if we're asked to find specifically the z-score, we're going to use our formula. But if we go over to Desmos real quick, let me show you how we can also get this data in another way. So on Desmos, if you click the little keyboard down at the bottom, and then you click Functions, you'll see a DIST, that stands for distribution. We want a normal distribution, so we're just going to click that normal dist. Okay, so here you see there's some parentheses, and you're going to put in two values there, your mean and your standard deviation. So our mean, remember, for this particular problem was 30, and our standard deviation was 10. Okay, and then I can click Find Cumulative Probability. Now, this is where it lets me set my minimum and my maximum. So my minimum, I'm going to put 0, and my maximum, I'm going to put that score of 27. And you'll notice we get a decimal right here. Now, this decimal is slightly different from what we were given when we calculated our z-score, but it's fairly close. It's 0.3807, so on and so forth. So again, roughly 38% are going to be less than that value of 27. So let's get back to our notes. All right, so the College of Knowledge gives an admissions qualifying exam. The results are normally distributed with a mean of 500 and a standard deviation of 100. So that's important. I'm going to underline that. The admissions department would like to accept only students who score in the 65th percentile or better. 65th percentile or better. Complete the chart below and then determine which students would qualify and what score is associated with the 65th percentile. Which students qualify for admission? All right, so here are our scores. All right, so the z-score part, we have to use that formula for, and then the percentile we will utilize Desmos for. Okay, so let's calculate our z-scores real quick. So remember, you're going to take your data point, so for instance 530. We're going to subtract our mean, which if I scroll back up, you'll see was 500, and then we're going to divide by our standard deviation of 100. So 530 minus 500, that's 30, and 30 over 100 is 0.3. So I'm going to put that z-score. And I'm just going to keep calculating my z-scores real quick. Feel free to pause the video and try it yourself. If you change the 530 to a 570, you'll get 70 over 100, which of course is 0.7. 650 is, you're going to get 150 when you subtract, and when you divide, you'll get 1.5. 800, when you subtract, you'll get 300, and of course, divided by 100, that's going to be 3. And then your last z-score, you're dealing with a data point of 540. When you subtract, you get 40. When you divide, you get 0.4. So those are all my z-scores. And now we're going to head over to Desmos and figure out the percentile for that, okay? So what I'm going to do, I already have this normal distribution stuff set up, so I'm just going to erase that mean, and I'm going to put in the mean of 500. And my standard deviation of 100. And so now we'll say, okay, minimum is 0, and what was our first data point? Our first data point was 530. So you'll notice when we calculate that, our decimal there is 0.6179, so on and so forth. So 61.79%. 61.79%. Okay, and we're just going to keep calculating those, and we're just going to keep changing what our max score is. So now let's say, okay, max score is 570. So that's going to put me at 75.8%. All right, what about 650? Puts me at 99.32%. Okay, 800 puts me at 99.86%. 99.86%. And then 540 puts me at 65.54%. So back to our questions up above. So we're asked for which students are going to qualify and what score is associated with the 65th percentile. So obviously these guys who scored a 530, unfortunately they do not qualify. All right, they had to be 65th percentile or better. So actually everybody down here will qualify. So it looks like a score of 540 will be right there in that range. We could play around and say, well, what if it was 539? Could I still qualify? Yep, I could, 65.17. What about a 538? Nope, I no longer qualify. So 539 is the lowest that you could get, and still be in that 65th percentile. So remember what it means to be in the 65th percentile. It means you have scored better than 65% of the people in that particular test. So here's a few more problems for us to try. So we've got, sorry, let me scooch over my screen a little bit because it's kind of on the edge of glory here. There we go. A normally distributed data set of 300 values has a mean of 35 and a standard deviation of 7. What's the probability that a value in the data set will be less than 41? All right, remember on your z-score table, when we're figuring out these percentages, it's always that amount that's less than that particular score. So let's head over to Desmos and put in this information. Sorry, everything shifted again. All right, so we're going to change our mean, and our mean this time is 35, and our standard deviation is going to be 7. Okay, and then we want less than 41, so just go down here. We're going to change our maximum to 41. All right, and we'll notice that we get 80.4%. 80.4%. If we'd been asked for the z-score, remember we could calculate it using our formula from in front, but we were only asked for the probability. So 80.43%. Now, that's what's less than 41. So to figure out what's greater than 41, well, you're just going to take 100% and subtract out that 80.43% to get 19.57%. To get what's between 33 and 41, well, I know what's less than 41. It's right here. Well, let's figure out what's less than 33. So we're going to go back over to Desmos, change our data point to 33. And we'll notice that we get a percentage of 38.75. So for 33, we get 38.75%. So that's what's below 33. We know it's below 41. That was the 80.43. So now we can just subtract those two percentages, and we will get 41.68%. All right, final problem. We've got the statewide math exam that tests 5,200 students. The scores are normally distributed with a mu equal to 81 and a sigma equal to 5, so mean and standard deviation. What percentage of test takers had a grade between 68 and 93 on the exam? So we're going to need to calculate two different percentages right here. Okay, so let's head over to Desmos. We're going to change our mean. So our mean this time is 81 and our standard deviation is 5. So we're going to calculate, whoops, did not mean to do that. We are going to calculate for 68, a score of 68. So that's not many people. You have 0.00466, so on and so forth. So if we, moved our decimal 2 places to the right, we're going to get about 47%. Okay, so for this guy, it's 0.47%, very minimal. All right, now let's talk about 93. So we're going to go back, we're going to change our score to 93. You notice that's a lot more people. So we've got 99.18%. Okay, so to figure out the amount or the percentage between that, we're just going to subtract those two numbers. So 99.18 minus 0.47, and that will get us 98.71%. Our next question asks us how many test takers had a grade that are between those two numbers. Well, remember, to get the amount, we're going to change the percent to a decimal, so 0.9871, and then we're just going to multiply by the total amount of students. And when we do that multiplication, we get 5,132.92. Of course, we can't have part of a student. So we know roughly you could have 5,132 or 5,133 students get that grade. So definitely well over the majority. Lastly, you scored an 87 on the exam. How does your score compare to the other test takers? Well, let's head over to Desmos. Let's change our score to an 87, and we'll notice that we get a decimal of 0.8849, so on and so forth. So 88.49%. What does that percentage mean? It means that we scored better than 88.49% of students. If we wanted to figure out how much specifically that is, 0.8849 times 5,200 gets you about 4,601 students. So you scored above 4,601 students. And that is Z-score and area under the curve.